Awesome. Wait, what happened? Okay. All right, guys. Welcome to beginner track this quarter. Glad to have you all here, and hope you're all excited. This is the first workshop of our beginner track, and so glad to have you all. At the bottom, you can see our feedback form. So it's in the chat as well. Jensen sent it a bit earlier, but we really appreciate your feedback. So if you could fill that out during the workshop, that would be great. Additionally, if you're keeping up with us on the ACM membership portal, we can drop a link in chat. If you want to mark your attendance for this workshop, the attendance code is Canada. And also a cool fact, keep track of all these codes, or remember all these codes for all 7 tracks, because there's a cool pattern with all these codes, and I think it'll be pretty cool if anyone can figure it out. So yeah. All right. I don't think Dustin is here, but I'll just talk about ACM AI as a whole. So ACM AI isn't just workshops, it's a lot of other things. But the biggest thing for ACM AI is to create and develop a community of students interested in AI, both at UCLA, but also like further in their careers and like in their lives. And so, to do that, we have 3 main sets of values. Firstly, to spread technical proficiency and awareness in AI, so making sure that everyone is aware of like of AI, like both methods as well as like what's in the news, as well as everyone's like capable of being able to work with AI and methods and programming pretty, I guess, fluidly. Second is creating a positive impact in society. I'm sure you all have heard about like ethical concerns about AI and like people wondering about that. And so there definitely are potential ways that AI can go wrong, but we're really committed to making sure that our use of AI has a positive impact in whatever way you can. And third, diversity and inclusion. AI is like I guess currently not the most diverse place, but we're trying to make it more and more diverse and have like let anyone get involved if they want to. So we're really committed to making this a really open space and really safe space for everyone to learn AI and machine learning. And to do that, we have 4 main initiatives, or subcommittees, you can call them. Workshops, which you're at right now. So if you're here, you've heard of one of our subcommittees. But workshops is what you're at right now. We basically provide workshops on different types of focuses of AI. So right now, this is a beginner track. We also have 3 other tracks we'll get to shortly. But they're really cool. Also, we have events. So every quarter, we run a couple of cool AI events that are really cool. Really recommend going to. Next, outreach. We do a lot of cool outreach at ACM AI. We have a couple of programs where we teach AI to high schoolers, which is pretty cool. And we have other programs as well. And lastly, but not least, projects, which is really cool. Basically, taking your knowledge from workshops or AI in general and applying it to really cool machine learning projects that we'll get to shortly. So yeah, I'll pass it on to Harsh right now to talk about projects.
What's up, guys? My name's Harsh. I'm an advisor for ACM AI right now, and I'm pretty heavily involved in ACM AI projects. So just wanted to come out here really quick and plug projects to you guys, and get projects on your radar for something that you could do next year. So essentially, what ACM AI projects is, Nikhil just touched on it briefly, but you get the chance to work on a real-world deep learning project. So currently, this quarter, we're offering 2 projects. The first is detecting diseases from images of leaves, specifically the Kossoville plant leaf. And then second is identifying humpback whales from images of their tails. So that second one is really exciting. It's basically like Face ID, but for humpback whales. So we're pretty hyped about that project. So if you want to jump onto ACM AI projects, we have a few requirements. The first is that you take beginner track, and then the second is that you take advanced track. So you guys are all in beginner track right now, and then we'll have advanced track during fall of next quarter, or excuse me, fall. Oh yeah, fall of next year. And then you can jump on to ACM AI projects during winter of next year, if you so choose. So we think like, beginner, advanced, and then projects is a very good progression for anybody that's, looking to get involved with AI, because, beginner will give you the foundations of ML and AI and get you those core concepts you need to succeed. Advanced will, take you a step deeper into neural networks and, real world techniques that are, being used today. And then projects will let you apply those techniques to a project and get you that real hands-on experience you need to succeed. So, if you guys have any more questions, feel free to, hit me up on Facebook or, DM me on Discord. But yeah, keep an eye out for ACM AI projects. Once again, we'll take you on after you've completed advanced track in fall of 2021. Thanks, guys.
Awesome. Thanks, Harsh. So yeah, join projects when you guys finish advanced track. It's really awesome and would recommend. All right, next shout out is, this is the last shout out, I promise. It's the AI podcast. And so on Outreach, we're actually they're creating a podcast called You Belong in AI, focused on diversity and inclusion in AI. And so what the podcast basically does is that they interview prominent individuals in the AI community and talk to them about their background, as well as their journey and through AI, as well as what they think about diversity in AI at the moment and how they can improve it. And so already 10 awesome episodes, and most recent episode just released this week. And so I think we'll send the link in the chat, but the link is right there as well in the slides too. All right, so what you guys are really here for is ACM AI beginner track. So let's get started with the basics about beginner track. So who's it for? And so beginner track is perfect for anyone who has little to no experience in machine learning. So if you don't have experience programming or doing any machine learning code, or even if you have a bit of experience but you want to refresh on things or learn machine learning, this is perfect for you. Yeah, minimal coding experience. And also, if you want a solid foundation in machine learning theory, there's a lot of cool guides out there in machine learning and like making code for models. But having a good foundation about the theory is really important as well. And so we'll be balancing both theory as well as code in this workshop. So you get the best of both worlds in this track. As for what's covered, we'll be going over the basics of machine learning, theory and implementation of simple models. So we actually working on a cool project later this quarter. That's gonna be awesome. And also be talking about a couple cool machine learning libraries, which are really useful in any facet of machine learning programming. As for meetings, you guys got here, so I'm pretty sure you know what meetings are. But every Tuesday from 7 to 9 p.m. Pacific Daylight Savings Time. Whoops. And before I go to the next slide, quick introductions. I'm Nikhil. I'm a first-year computer science major, and I'm on the workshops team. And
my name is Jensen, and I'm a second-year computer science major. I guess I'm also on the workshops team.
Awesome. Yeah. So now you guys know us. We'll be helping you guys do this 7-week series. And so, yeah, looking forward to meet all you guys, as well as teach you guys about machine learning. So going through, I guess, all our workshops in general. So we have beginner track right now, which is about like the basics and fundamentals of machine learning. If you guys don't know what these two are, implementing linear and logistic regressions, don't worry about that right now, but they're two pretty cool models that we will be going into in beginner track. Next quarter, I guess fall quarter, we'll be having an advanced track as well, which is more about deep learning. So if you guys have heard about deep learning before, it's about like deep neural networks and those sort of things that are really popular right now in computer science. And so this track will require some basic knowledge of machine learning concepts like linear and logistic regression. But after you guys finish this, after you guys finish beginner track, you'll be perfectly ready to teach advanced or to go to advanced. And then we also have a course called Advanced Plus Plus, which is, I guess, a bunch of various more, I guess, varied concepts in machine learning. So a bunch of really cutting edge models like transformers, autoencoders, and quantum ML. And so for that, you need a bit more knowledge. But again, after you take beginner track, you can at least understand both of these other tracks as well. So this is the perfect place to have that great foundation. Office hours. So usually we have office hours to basically answer any questions about the track. As of now, we haven't fully decided on them. So as you can see, date and time are to be decided, but we'll let you know by next meeting when office hours are. Advanced plus plus and projects, yeah, you can. You can be in both of them. So we'll be pretty sure to make sure that in fall, or I guess whenever we teach advanced plus plus, we're not gonna make them make it conflict with projects. So if you wanted to, you could take advanced plus plus and projects. So yeah. All right, quick look into our schedule. There's a lot of complicated words in here, so don't worry if you don't get all of them or any of them. We'll go over them all week by week. So today, we'll be going into machine learning, like kind of diving into what it is, how people typically do it, like the basic concept behind it, as well as going into a bit of Python, which is pretty important for machine learning code. Next week, we'll be going to Python and a cool model called K-nearest neighbors, which is actually pretty cool if you think about it. Week 3 and 4, we'll be talking about two regression models, a linear and logistic regression, which you might have heard about before, but we'll be actually looking into the code behind it as well as how it works in theory. Week 5, we'll be looking at two cool libraries called NumPy and Pandas, which are really important in machine learning. And week 6 and 7, we'll be going into our really cool guided project, which will let you guys get a taste of machine learning and coding by yourself, as well as apply some of the concepts we learned in the previous weeks. Raghav asks, or if you're unable to come to a meeting due to midterms or other commitments. Yeah, so as Jensen said in chat, we're recording these workshops, and so we'll be posting them to YouTube on our YouTube channel. If you guys joined the Discord, link is here. The link will be posted on Discord, but also if you guys just go to the ACM AI YouTube channel, I think we can link that soon. You'll find it there as well whenever we release it. All right, so it's a couple big words, a couple big things people usually talk about machine learning when they haven't, I guess, gone through it too much, is that it can be really scary and daunting. A lot of math sometimes, also a lot of computer programming. And so don't worry, we'll be here. We'll be helping you through all the details, and we'll try to make it as intuitive as possible. And so on that note, if you have any questions or comments whenever I'm talking, just feel free to unmute and ask them, or write them in chat as people have already written. And so we're always available to answer you guys' questions, because that's the most important thing to answer. Cool, so let's dive into AI and ML, but focus on real life examples. So first, computer vision. I'm sure you guys all have heard this word somewhere in the news or on articles before. It's really popular right now, mainly because of autonomous cars. And so as you guys can see on the left, this is a pretty cool model being run on camera data from a car, on a car. And so what this model is doing right now is, you can see it's actually finding all the objects that are important in the image, drawing boxes around them. So you can see like yellow boxes, green boxes, and after it has that box, it's actually figuring out what's inside the box. Like, is it a bike? Is it a pedestrian? Is it like a fallen tree? Actually, there's no fallen trees here, but the point still stands. This model is classifying things, or is finding things and also classifying them. And so that's a pretty cool part about computer vision. People typically use something called convolutional neural networks in this field. The word sounds really complicated, but basically what this does is that these models are used to turn images into like classifications. We'll dive into it more in advanced track, but this is a quick look into I guess how widely applicable machine learning is. Next thing is healthcare. And so machine learning is pretty helpful in trying to figure out or like classify certain diseases or problems in people's like health scans and things like that. And so something that's really cool right now is that deep learning techniques can often either keep up with or outperform trained specialists in recognizing certain problems in, I guess, samples or images. And so, as you guys can see here, for potential data we might have on the left like this healthy, like this healthy sample, and then on the right we have a disease sample where you can see hemorrhages and things. And so we might pass these into a model, and it will learn to figure out which one is which one's healthy, which one's unhealthy. Even cooler actually is that when working in tandem with humans, these models are actually a lot more accurate in combination. So it really opens a lot of cool avenues for machine learning plus humans in combination. Next thing is natural language processing. I'm sure actually you guys all have phones. So if you go on your phone and say like, "Hey Siri" or "Hey Google," this is natural language processing at work. Oh, what the heck? Siri turned on for me. I should not have said "Hey Siri." Why did I say it again? It's okay. Same. Point still stands. It's really popular right now. Voice assistants are really popular right now. Natural language processing goes beyond that. It can go into text to voice or voice to text, or even like future things. But it's a pretty broad subject that goes into a lot of just like figuring out the important patterns in words and like speech. And so you can see how important it is in general. And so I guess it's been breaking through recently, but really cool example of how machine learning is really prevalent in our lives right now. All right, so we went through these 3 examples. And so now diving into a bit of the intuition behind machine learning. And so like we'll be going into like what's actually happening, or we describing what's actually happening, as well as how it might work out. And so to do that, let's play a game. So this is gonna be pretty fun, I think, at least. And so we're playing a game called 50-50. It's a pretty cool way to think about how machine learning models train in general. It's not exactly how machine learning models work, but the general concept is pretty like similar, I would say. So it's gonna be a cool game adapted to online purposes, but it's gonna be using the poll feature on Zoom. And so the goal of this game is to figure out the letter of the alphabet such that half of your names, or half of your first names come before the letter, and half of them come after. And so to do that, we're gonna start, because let's say we don't know what your guys' names are. So like we close Zoom and we can't see you guys there anymore. So we're gonna just choose a random letter to start with, and then we're gonna make our guess even better, or make our assumption even better over time by updating our model. So give me 1 second. There will be a poll on your screen, but first we need to decide on a letter. Yeah, give me 1 second about that. So we will be starting, because we don't want to get, we'll be starting with the letter, what's a good letter? All right, I'm going to be starting with the letter, current letter is going to be W, okay? You may be wondering why W, because W's are for wins, so we're taking W's. But it's also going to be not going to be the best option, because as you guys know, the middle will, oh shoot, oops, I did not type in the correct chat, but there you go. Everyone can see that now. Current letter is W. So I'll be launching the poll right now. And so if you guys can respond, current letter is W. So let me, or type in if your name starts before, or if your first name is before or after W.
Wait, let me share screen from my iPad real quick.
Yes.
1 second.
All right. How many people do we have today? 20 minus 2. All right, we got 16 out of 18 responses. Waiting on two of you guys. I'll keep the poll open for a little bit longer. So maybe the 2 people can respond. This is a pretty clear trend, which is what I expected. Actually, I'll ask you guys, what do you guys expect with this current? Like, which option do you guys think will be winning at this moment? Just shout it out or write it in chat. Before. Nice. So here, I will end the poll right here, and we'll see if you guys are all right. Well, I can already see it, but you guys will see. Let me share results. And so you guys can see, yeah, you guys are actually super right about that. And so a whopping 94% of people have their name start before W. While one person isn't, which is pretty cool. That your name starts after W. That's pretty cool, I would say. But yeah, so it's a pretty big difference. So based on that, what do you guys think we should do to our chosen letter? Should we increase it or like go backwards in the alphabet or go forward in the alphabet to make that better? Go backwards. Yeah, exactly. So because we have so many people before our current letter in the alphabet or our chosen letter in the alphabet, we want to shift back or shift backwards so that we get like a more 50-50 proposition. So what do you guys think is a good letter to go with? M, L. It's 50-50 right now. I need some more opinions on M or L. 2 M's, okay. 3 M's, wow. Oh, N, this is unique. Okay. This is a toss up. I think I'm gonna go with, yeah, let's go with M to see how it goes. Right again. I see Riley, I see how it is. Well, you were pretty contrarian, so I guess it worked out. So let's go on to making it around M. So I'll send the poll again. So now we have the current letter is M. And so respond again, but with the current letter being M. All right, we have everyone but 2 people. I'll give you 2 people, let's say 15 more seconds to answer. No rush, but I want to keep moving on. Oh, Jeopardy music's kind of loud. All right. All right, 15 seconds are over. Let's see. Or first, before we say to see the results, what do you guys think will happen? Is it going to be more even? Wait, should we talk about this? Is it going to be more even or more close? Or what do you guys think is going to happen with this new letter? Better than last time? Yeah. All right, let's see it. Ending the poll and sharing results. So as you guys can see on the iPad, this is a lot better than last time. We have a lot of people, or we had 94% before in the first iteration, but now only 56%. Additionally, we have only six people after, which is a lot more than one person, and we have 1 person right on the spot. And so this is pretty good, but we can be better. I think we can be better. We have 16 people, so we can actually probably do 8 and 8 or like 7 and 8 and 1. So what should we do? How should we change the letter to make it even better? L. So going backwards again. Yeah, I agree. Anyone else? L is L the consensus, or is something else the consensus? K. K and L are pretty close together. Yeah. It's a 50-50. I need some more voices. Need to break the tie of 50-50s in here. Any other ideas? 2 Ks. Okay. 3 Ks. Nice. Okay. Okay, that's good. Good job. All right, let's go to I. Okay. I is pretty interesting. Let's go to K because everyone's at K. We can talk about what would happen if we did I afterwards as well. So let's do this again. Hopefully we're perfect this time, but let's do this again. Oh, whoops, why did I share again? That was my bad. All right, third time is the charm, as they say. So current letter is now K. So answer the poll again. Hopefully one last time with K as the current letter. Okay, 4 more people. No rush, but also the faster the better, I guess. Three people. I'll give everyone 15 seconds more from this point on, just so we can move on to the next thing. All right, cool. So we only got 15 responses this time. It's a bit harder to get even, but here you guys can see what happens. And this time it's a bit different. It's actually 40 to 60. So it's just better last time. It's like can't be for sure because like one person didn't respond last time. But you can see it's a bit closer to even compared to 56-38. I think, yeah, 56-38. So we couldn't find a perfect medium, but K and M are pretty close. If we went to L, we'd probably get the right answer or a better answer. But the point still stands is that this exercise at its core really describes how machine learning models work in general to like a certain point. So we had our guess start at W, which we know obviously is pretty wrong, but let's say we didn't know W was a bad guess. We started at W, and then we noticed from the data that we had, everyone talking to us and everyone filling out the poll, we noticed that from that that we were pretty off. We were actually like really off. We were like 94 to 6. That's pretty bad. So as a result, we adjusted our current letter guess to M, which is going to make the mean a bit better. And so we tried again, and we got even closer. We're not perfect yet, so we tried it again with K, and we got maybe a bit closer, but we can keep adjusting more and more over time. But you guys get the point. Is the whole point is that we have like an estimate or hypothesis. We test it we check how good it is on data, and based on how bad it is, we adjust our hypothesis to better suit our data. It's a bit different in typical models because we're usually using different data for every iteration, but the point still stands in general. Awesome. Any questions about that activity or thoughts while I share screen again? If not, we'll keep on going. All right, cool. So awesome game. I hope you guys thought it was fun. If not, tell us in the survey or the feedback form. So next thing, so we talked about a bit about in general, like intuitively how ML models kind of work. But let's go into exactly what it is. And you can see on the right side the cool KCD about how machine learning is typically described. And so they basically talk about a machine learning system on the right, which is a big heap of stuff, and how people pour a bunch of data into it and then keep stirring the pile over and over again until they get the right answer. And so while it's a bit true that machine learning is a bit of a black box, there are ways that we can learn about the math and the algebra as well as the programming style itself to better optimize and make this process even better and less random in general. So yeah. So the first thing is talking about our vocab words right here about AI, machine learning, and deep learning. And so AI is a pretty broad subset of things. It's actually the broadest category. But basically AI, we'll get into the actual definition in the next slide, I'm pretty sure. But AI is the biggest thing. It's basically any code that you write that isn't like the program going like robot move forward 5 feet and then go left 6 feet. Basically, it's adapting to different situations. So it takes in data such as like how far away am I from like the food or something, or from a mouse robot, and then figuring out the optimal route to that food or something, that cheese. And so that's AI. It's pretty broad. We'll go into like more certain, I guess, more specific definitions soon. And a subset of that is machine learning. And so machine learning, typically more model based, but it usually involves something called, I guess, learning, where basically we'll be figuring out, like, based on a bunch of data, we'll be pulling a bunch of data in, and we're basically from that figure out general patterns, general trends that we can use to better classify the data or make a good hypothesis about the data. And so an example of this could be a model that we'll get into more details, but for example, it could be a model that takes in a bunch of data about houses and their prices and figures out how to estimate a house's price based on a bunch of details like number of bedrooms, number of bathrooms, things like that. And then the smallest subset of that is called deep learning, which is pretty mainstream nowadays. Did not used to be this way, but basically this is all the neural network stuff where basically we're pumping in a bunch of data into a model, like a lot of data. And we're basically telling the model, here's the data. You figure out by yourself what the general weights are going to be and like how you're going to predict it yourself. We'll give you a general structure, but you figure it out yourself. So it's the most hands-off approach, but it also has been working really effectively recently. And so going into the definitions themselves, so artificial intelligence is basically, I guess as a concept, it's basically the theory and development of programs to do tasks that normally require human intelligence. So like, for example, path planning or finding a line of best fit, those type of things. And so, yeah, some examples include translation, making decisions like this decision tree. So like, let's say you work at a bank and you want to figure out, should I give this person a loan given all their data? So you may want to say if they like make less than, or if they make like a certain amount of money, we're going to give them the loan. Otherwise not, don't do that. So that kind of thing works in the decision making. And some visual perception tasks also fit in that area. And machine learning, as we talked about last slide, is like a certain subset of AI where basically we're going to be telling the computers, we won't be telling the computers what to do. We'll be giving them a framework where they can learn, which they can use to learn about data and like a bunch of things in life, I guess, without being like explicitly told how to learn. So basically, we can be giving them like a bunch of housing data, and they can learn to figure out how to approximate housing prices. And so breaking that down into smaller steps, there's, I guess, three main parts. There's more like many parts as well, but 3 main parts in the pipeline. Starting off with data. And so data is like everywhere. It's talking about important information about like a topic, anything. It can be like housing data. It can be like student data. It can be anything. It can be like computer data, like how much time do you spend on like YouTube every day, which is too much for me, but same thing. Next part is training the model. And so once you have your data, you can create a general model that we'll talk about more in the future, but like what the model is. But we're basically making a general model that has like a framework to learn about the data. And so we'll be giving the data to the model to learn like a general formula. So like rely on a best fit or something like that. And so after we've given the model a bunch of data and made it pretty accurate on that data, we can go to inference. And inference is a step, which is typically the last step, where basically we can apply our model to real life situations. So let's say we have a model that based on like your data figures out if you're going to fail the midterm or not. And so now that we have that, given a random student, we can figure out the odds that they're going to like fail their week 5 midterm, which is hopefully low, but their point still stands. So yeah, and so breaking them down a bit more, so we start with the data. So the actual input data is at the very beginning, and so next step in between training and data is called pre-processing. And so this involves getting rid of bad data like outliers or like incomplete data, as well as scaling data to the proper size, like normalizing your data set and all. Next step is training. So training involves helping having your model learn the proper weights or parameters. We'll get into what these are soon, so that it can represent the data well. And so the training step basically allows the model to learn about the data and make the best model of that data possible. Next step is testing. And so testing is going to go into, can we apply this, actually, no, this is before inference. So this testing is basically figuring out, okay, we trained our data, we trained our model on like a certain set of data. And so we want to figure out, before we apply it to the real world, we want to see how well it does on other data. So let's say we trained it on like the first 100 samples of data. We want to figure out how well a model trains in like, let's say like another different set of 20 data points, for example. So we want to see if it hasn't seen something before, is it still pretty good at estimating it? And then final step is inference. We talked about that before. And so again, this is a lot of stuff, but we'll be focusing mostly on training and inference and testing this quarter, or this workshop. So don't worry about it too much. This is just a general pipeline. And we'll get into more detail on certain parts of it and not talk about the whole thing, but this is a general pipeline. So given that, let's talk about something. So I've been alluding to this a lot, but let's say you were asked to estimate what a house's price was. And so what would you ask for to figure that out? Like what information would you want to figure out how expensive a house was? Like what data, for example? Like what types of data? All right, now it says location, definitely. Location is really important. Certain places are more expensive than other places. Bedrooms and bathrooms, yes. So more bedrooms and bathrooms is typically a good thing for price. Square feet, awesome. Yeah, so bigger house, typically more money. So yeah, all those are really great. How modern update it is, yeah. So having a more modern house or like having more like recent appliances and stuff, or like recent furniture, or I guess that like house model and stuff like that is really important for making it more expensive. And so all of those factors and more can be really useful for training a model, or like, for example, for you to estimate how expensive a house is. And so given those data points, what do you guys think the output of a model will look like? Like, what will it be, a number? Will it be like a bunch of and what will those numbers be? I guess a better question is it going to be continuous or categorical? And so continuous means like a bunch of numbers in a row. Categorical means, is it big or small, or like categorical, like this or that? Kind of a mix. How so, Maxwell? Do you mind elaborating? Wiley and Noah say continuous. Oh, okay. Yeah, so you are right that the like so many inputs might be categorical, like location. But in terms of the output, with the output, I will have to agree with Riley and Noah here that the output will be continuous, because it'll be like a price. So like, is it like $500 or like $5 million, that kind of thing. So it can be a bunch of numbers on on like a continuous spectrum. But you are right, Maxwell, that some of the inputs are categorical, and so in the future we'll be diving into how to deal with both categorical and continuous data, both inputs and outputs. But this is just the general way of how models might work in machine learning. All right, pass it on to Jensen.
All right, can you guys see my screen?
Yeah, we can see it.
Okay. Let's spend a little more time on the intuition behind AI. All right, so let's start with an example here. So how does a human know the difference between a cat and a dog? Did someone teach you what to look for? If so, what are some specific features that would distinguish a dog from a cat? Any suggestions here? Pointy ears, yes. Snout, perhaps. May not always work, I guess. Yeah, I guess some of these features might not work like 100% of the time, but it's still like useful most of the time. So yeah, I think cat has longer whiskers. Okay, so those are all like really good answers. The key here is every time you got it wrong, your parents would tell you what the correct answer is, and you would be slowly able to learn the differences between a cat and a dog. And eventually, after many iterations of trial and error, you can successfully distinguish a cat from a dog. So AI models in the real world follow a very similar theme. For example, AlexNet, which is a fairly well-known image classifier, has been trained on millions of photos of different objects, also known as the ImageNet. So here are some pictures from the ImageNet that the model has been trained on. So at the beginning of training, the model is basically just gonna be guessing randomly because it hasn't seen any of these images before. However, whenever our model makes a mistake, then we'll first correct our model. So we'll tell the model what the correct label should be for that particular image. And then we're sort of gonna nudge our model in the right direction through a process known as a gradient descent. So after many iterations of training, our model would slowly be able to recognize patterns within our training data, and then it would, in principle, be able to classify different images, provided they're not too dissimilar from the training data set. All right, any questions? All right, if not, I'm gonna move on to the next part, which is about Python. So in this workshops, we're gonna be using Google Colab notebooks mainly, which will come with all the packages pre-installed. However, another alternative here would be the Anaconda distribution, but it's not required for this workshop series, but it is quite popular within the data science community. And the last part of this workshop would be a coding tutorial with Python. So let's get right into it. So I'm just gonna start with a blank notebook here, but I think there is a reference here that you can refer to. All right. I guess let's begin with operators, specifically arithmetic operators. Let me add a markdown cell. All right, so let's start with the plus operator. So the plus operator adds two numbers together. So for example, 5 plus 2 would be, give me a second. All right, so 5 plus 2 would be 7. So nothing surprising there. The next operator is the minus operator, which subtracts the second number from the first number. So 5 minus 2 would be 3. All right, next we have the star operator, which multiplies two numbers together. For example, 5 times 2 is 10. So hopefully nothing surprising there. And next we have our slash operator, which divides the first number by the second number. So I actually have a question for you guys. What is 5 divided by 2 in Python? This is not a trick question. Let's see. A lot of people are saying 2. Maxwell is saying 2.5. All right, let's see. So it turns out 5 divided by 2 in Python is in fact 2.5. So that may come as a surprise for some people. But what if you actually want to do integer division in Python? So how would you do that? So the answer is using the double slash operator. So 5 integer divided by 2 would be 2. So this is slightly different from other languages such as C and C++, but just keep this in mind. Outrageous, yeah, I know. All right, I guess somewhat related to the notion of integer division is the mod operator, which mods the first number by the second number. So for example, 5 mod 2 would be 1. And 1 is the remainder when you divide 5 by 2. So it turns out in Python, you can also apply the mod operator to floating point numbers. So 5.0 mod 1.5 would return 0.5. So this is also a little bit interesting. This is something that I guess I didn't know until recently. All right, give me 1 second. All right, next we have our, I guess our double star operator. So which I guess raises the first number to the power of the second number. So for example, 5 to the second power would be 25. All right, so that's about it for arithmetic operators for now. Let me see if there's any questions. All right, if not, I'm gonna move on to the next part. Let me add a markdown cell here. So the next part is about variables. So hopefully you guys have some experience with variables, but yeah, but like programming experience is not required for this workshop. So we're just gonna start from the basics and then we're gonna move on to some more advanced concepts. Oh, Markdown Style is just a box that contains like text. So you can see like I can add a cell with like that I can type code in, and I can also add a cell that I can, type whatever text in I want. And this would not like be executed by the notebook. Oh, that was a joke. Oops. Okay. All right, so in Python, you can declare a variable by assigning a value to it. So for example, I can do x equals 2, and x now has the value of 2. You can also declare variables in terms of other variables. So I can do y equals x plus 1, and y would have the value of 3. Okay, so what happens if I change the value of x? Like, does anything happen to the value of y? Any ideas? No. All right, let's run the cell. So it turns out y is still 3. So Maxwell, you're in fact correct here. The reason here is because we changed the value of x after assigning it to y. So nothing happens to y. I guess another peculiar thing about Jupyter Notebook is the Colab notebook actually preserved the states of variables. So if I do x equals x plus 1, and then x here would be equal to 1 because I assigned the value 0 to x in the previous cell. So if I run this, if I were to run this cell again, like what's the value of x going to be? Any ideas? Okay, Matt Wang says it's gonna be 2. So let's see. Okay, so it's in fact 2. So Matt Wang is correct. Good job. All right, so if I were to run this cell again, it will be 3 because every time I'm adding 1 to the value of x by doing x equals x plus 1. And as I said, the Colab notebook preserves the state of the variables during the course of a runtime. So just make sure like you're aware of this so you don't end up like running a cell like multiple times and then like getting some unexpected results. So this is just like a heads up for using Jupyter notebooks. All right, so the next part of our tutorial is going to be on strings. And you can declare strings in Python using single quotes or double quotes. For the most part, they're like interchangeable. So let me give you an example. So let me create a string with hello world. Let me print out the string. So the string now has the value hello world. You can also do the same thing with double quotes. So another string is, I guess this works too. Okay, another string now has the value. This works too. However, if you want to include quotation marks or apostrophes inside a string, then you have to use double quotes. So this is something that you have to keep in mind. So can use single quotes because I have an apostrophe here, so I have to use double quotes for this particular string. Now the value. Yep. All right. Any questions? Are there escape characters in Python? Yes, I think so. Let me give you an example. So for example, I think you can do the new line character. Let me add something before and after. I actually never tested this, but hopefully it works. Oh, this is awkward. Did I not do this correctly? Or do I have to use like backtick or something? Wait. Nick, here you have experience of I guess escape characters.
I think you're right. I think it's meant to print it explicitly because it's Jupyter notebooks. I'm not sure.
Oh, okay. All right. I guess it doesn't work with escape characters.
You might want to like type in like print in parentheses instead. I think that might work.
Oh, okay. Let me try this. Yeah, maybe it'll work with print. Okay, so it works with print, but it doesn't work when you just print out this string by typing its name. All right. So the next part is going to be about the print function in Python, which is the main way to output data to standard out. So let's see here. So let me declare some variables just for the sake of this example that I'm going to pull up. All right, so print can take in one argument. So if I do print name, then I get George. You can also pass in 2 arguments into a string. So we pass in the string literal my name is as the first argument and the variable name as the second argument. And then you get, I guess, both arguments printed on the same line. You could also format, I guess, what you print out with the F string. So let me give you an example here. So I can do my name is, and then with, I guess, curly brackets name. And I'm curly brackets years old. Let's see what this prints out. So as you can see, this F string format is able to format your string fairly nicely. So this is the same with using the string.format method that some of you might be familiar with. So let me add a comment. So some of you might do the same thing with, let me copy this. Save some time. Right. So I call the format method on this particular string, and then I pass in the variables that I want to be in the curly brackets. So as you can see, this gives me the exact same result. You can also format a float within a print statement. So for example, I can do print and then %.2f, and then I can pass it a float. I guess something random. So this basically rounds the float to 2 decimals, which is what %.2f means. All right, any questions? All right, if not, I'm gonna move on to list, which is a pretty common data structure in Python. So I guess another way to think of a list is it's a container for data. So let me first declare a list or define a list. I'm just gonna give it some basic values. All right, so this is one way to define a list. You could also have different data types inside the list. So you can have, I guess, a string as your first element, and then an int as your second element, and a boolean as your third element. All right, let's see. Is there any questions? Okay. I think the question is being answered. So you can also have a list nested in another list. Let me give you an example. So you can have, okay, let me define a list, and then I can nest another list inside of this list. And then I can do this like however many times I want. So I can nest another list inside this. I think think the syntax should work. Hopefully. Okay, it works. You can also append elements to your list with the append method. So I can append 9 to numbers. And then I get 9 as the last element in this particular list. You can also retrieve an element by specifying its index. So if I do number sub 0, I get the first element of numbers, which is 1. Could also do number sub 1, which gives you the second element, which is this 3-element list. So something to note is the indexing in Python starts at 0. So just keep this in mind. Let me write this down as a comment. All right, so let me give you guys a question. So what is, hold on. So what would this output? So what's the output of this? Any ideas? What does number sub 2 sub 2 sub 0 would output? 7. All right, let's see. Yep, it is in fact 7. So the way you would figure this out is you would look at this list and then you figure out the third element because of the index 2. So third element is this nested list, and then the third element within that nested list is this list containing 7 and 8, and the first element within this is 7. So let me this is a comment. All right. So you can also do some interesting operation on list. In particular, I'm talking about list splicing here, or list slicing. Let me create another list to give you an example. So again, my list is 1, 2, 3, 4, 5, and then I could slice this list by specifying a starting index and then ending index. So note that the starting index is inclusive, but the ending index is not. So I guess the my list sub 1 here would be 2. So that's included. Our my list sub 4 is 5. So we're going up to the number 5, but we're not including it. So let me just specify it's not inclusive. Bear with me here for a second. All right. So you can also leave out one of the indices when you're doing list splicing or list slicing. So if I specify the first index as 3, then if I leave out the second index, then it will just go to the end of the list. So my list of 3 here is 4, and then it just goes all the way to the end because I didn't specify the ending index. So similarly, you can leave out the starting index. So this would start from the beginning of the list and go to all the way to the third element. So I got 1, 2, and 3. And then you can also do negative indexing in Python, which is again a little bit peculiar. So if I do my list sub -1, then I get the last element. And you can also do list splicing using negative indices. So if I do -:(-1), then I get the first n-1 element of the list. All right, any questions? All right, seems like everything is being answered in the chat. All right, one last thing is you can also reassign an element in the list. So if I reassign the first element in numbers as a string, then it prints out this list. And I get, so the first element here is replaced. So yeah, that's basically all I want to say about list. If there's no questions, then I'll move on to dictionaries, which basically holds key value pairs and is a pretty useful data structure in Python. All right, so one way to define a dictionary in Python is just by enumerating all the key value pairs. I do apple is equal to 1, banana is equal to 2, and orange is equal to 3. Turns out what's in my dictionary. So it looks something like this. You can look up an element in the dictionary by, I guess, specifying its key. So the key here is banana, and the value is 2. You can also reassign the value for a particular key. So if I do my dictionary and then supply with the key of apple and equal to 1, and the dictionary is going to be updated. All right. Any questions? Seems like there's some activities in chat. Okay. I think the question is answered in chat, so I'm just going to move on. All right, so a useful method for dictionary is the keys method, which basically returns all the keys in your dictionary. So as you can see, we have 3 key value pairs in this dictionary, and the keys method just returns the keys for all those key value pairs. Another useful method for dictionary is the items method, which returns all the key value pairs in your dictionary. So as you can see, all the key value pairs are represented as a tuple. And then, yeah, basically all of them are being returned. Let's see. Okay, there's a question in the chat. In the dictionary, what needs to be a string and what doesn't. So there's not actually a requirement on like, so it doesn't have to be a string. Like, for example, I can just do like, let me give you an example. So I can change the key here. I can give you an int. One. Okay. So this still works as expected. So nothing has to be a string. So a dictionary works with like, so the key can be an integer or a string or like any other, I guess, data types. And the same thing applies to the value. Oh, and one more thing, the key has to be immutable, because if it's not immutable, then it's not hashable. So that's one thing that you have to keep in mind. But I think most fundamental data types in Python are immutable, so they would work as keys. All right. However, like an example of a data type that is not immutable is a list, because you can change the value inside a list, as I showed before. So I reassigned the value of a list. So you can use a list as like a key, for example. All right. Let me move on to the next part, which is about comparison operators. All right, so the first comparison operator is the greater than operator, which returns whether the first operand is greater than the second operand. So for example, 5 greater than 6 would return false, because this is not the case. Another related comparison operator is the less than operator. And similar to the greater than operator, it returns whether the first operand is less than the second operand. So is 5 less than 6? The answer is yes. So it returns true. So you can also do, if you want to do less than or equal instead of less than, then you can add an equal sign after the operator. So for example, is 5 less than or equal to 6? The answer is yes. So same thing for the greater than operator. You can add an equal sign to make it greater or equal. So for example, is 6 greater than equal to 6? The answer is yes. And another comparison operator is the double equal operator. So this is distinct from the single equal operator, because a single equal operator is the assignment operator. So when I did x equals to 1, I'm assigning the value of 1 to a variable x. But the double equal is comparing whether 5 is equal to 6. So in this case, the answer is going to be false. And last, there's the not equal operator, which is denoted by exclamation mark and equal. So for example, is not equal, or is not equal to the string equal. Also a mouthful. So the answer is yes. So this returns true. All right, any questions? If not, let's move on to logical operators. All right, so the first logical operator that I'm going to cover is the AND operator. So the AND operator returns true if and only if both operands return true. So for example, I can do is 1 greater than 2, and if is let's see, is 3 also greater than 2. So the answer here is false, because 1 is not greater than 2, even though 3 is greater than 2. So one of them returns false, so the whole expression is false. Another logical operator that is quite common is the OR operator. So the OR operator returns true if one of the operands returns true. So let me use OR on the same example. So this would return true because 3 is greater than 2, so it doesn't really matter whether the first condition is false. So another logical operator in Python is the not operator. So this negates whatever is followed by this operator. So if I do not true, then I get false. Similarly, if I do not 5, not equal to 6. So here's a double negation here. So what is the output of this? Anyone has any ideas? False. Yep. All right, so someone in the chat asked whether double ampersand and double and double or is being used in Python. The answer is no. You would literally like type out the and the or. So this is only used for this is not valid in Python, but it's used for C and C++. So I guess that's where you would learn that from. All right. If there's no more questions, then I'll move on to the next part, which is going to cover if-else statements. So this sort of combines, or this would require the knowledge we learn for logical operators to work. So the way you define an if statement in Python is you use the keyword if, and then this is followed by a condition that would either return true or false. And you also need the colon here. So if this condition is true, then the following line is going to be executed. So let me give you an example. Is if 2 is greater than 1, then execute print 2 is greater than 1. So I need this in a string. So this line is going to be printed. However, if this is not true, then nothing happens. All right. So you can also, let me copy this to the next cell. You can also have like make more complicated if-else statements with the else if, which is spelled elif in Python. And also you don't need this parentheses. I don't know why I have it, but it also works with parentheses, so don't worry too much about it. So I can add another condition by using elif. And then again, if this condition is true, then the following line is going to be executed. If it's not true, then it's not going to be executed. In this case, because both are not true, then nothing is going to be executed. And finally, I can add the else clause, which would get executed if the first two conditions are false. So this would print 2 is greater than 1, because 2 is not less than 1 and 2 is not equal to 1. All right, any questions? If not, I actually have a interesting exercise for you guys to work out. So I'm going to start typing. I'm going to give you a number. If this number is greater than 90, or number is less than 0, then print A. And then else if the number is equal to 100, or number is greater than 120, then, or actually it's greater than equal, then let's print B. And then if the number is greater than 0 and number is less than 200, print C. And lastly, print D. All right, so what do you think the output is? All right, ACD. Yes. So A is printed because the number is greater than 90. So it doesn't matter if the second condition is false. And then if the first condition holds, then it doesn't go to the second else if clause. So this is skipped. And then next I have a completely new if clause here. So because the number is greater than 0 and the number is less than 200, then C is printed. And here is kind of like a trick, because like this D is technically not inside of so in Python, if you want to use an if else statement, then the stuff inside of the if clause has to be indented. So because this line is not indented, then it would consider to be outside of the if else clause. So indentation is actually part of the syntax in Python. So just make sure to keep that in mind. So yeah. All right, so any more questions? If not, I'm gonna move on to the next part, which is gonna be about for loops. I think we're doing okay on time. I'm just gonna continue. All right, so actually before we cover for loops, let me introduce the in keyword in Python. So let me define this list again. And then the in keyword will return whether an element is in a list. If I do is 10 in my list, so the answer is no, so it will return false. However, if I do is 4 in my list, this would be true because 4 is in fact part of my list. So you can iterate over your list using this in keyword like so. So for I in my list, so this would iterate through all the elements in your list, and you can print out the element. So you get 1, 2, 3, 4, 5. But it will be pretty annoying if you have to define like a list every time you want to write a for loop. So Python has a solution to that, which is the range function. So for example, I can do for I in range 10, and it would go through all the elements that goes up to 10, but not including 10. So it starts from 0, and it goes all the way to 9. So the ending index here is not inclusive, which is also the same for list splicing, which we covered a while ago. But the range operator can also take 2 parameters. So if you pass in 2 parameters, then if you look at the documentation here, the first parameter is going to be the starting index, and the second is going to be the stopping index. So if I do for I in range 3, 8, then I would start from 3 and then go all the way to 7, because again the ending index is non-inclusive. So the range function can also take in 3 parameters. So the third parameter in this case is the step size, as you can tell from the documentation. So the step size here is 2. So let me run this cell. So I'm starting from 4, and then I'm going like step size of 2 at a time. So 4 goes to 6, 6 goes to 8, and then 8 goes to 10, but the ending index is not inclusive, so 10 is not going to be visited. You can also, I believe, go backwards. Let me give you an example. So I can do like 4, 10, or wait, hold on. Let me do 10 and then 1 and then -1. So this should go backwards. So yeah, this goes from 10 all the way to 2. So this is how you would iterate backwards. All right, any questions regarding to for loops? All right, if not, I'm gonna move on to while loops, which is pretty similar to for loops, except I guess the syntax is more similar to the if else statement, but you basically you start with the keyword while and then you have a condition. So the while loop will run until this condition no longer holds. So let me give you an example. So let me start with a counter variable, and then while count is less than equal to 10, then print count, and then increment count by 1. So, okay, so I didn't show you guys what the plus equal operator is, but basically it's equal to count equals, oh wait, I did double slash, count equals count plus 1. So it's the same thing as this, but it's the shorthand. So you can't do a count plus plus in Python. Unfortunately, that is not a thing in Python, so you're gonna have to stick with a count plus equals 1. So yeah, this is basically doing the same thing as a for loop, except the syntax is slightly different, but it's very similar to a for loop. So I'd say like get comfortable with one of these syntaxes, and I think you're good to go. All right. The next topic that I want to cover is list comprehension in Python. So what do I mean by list comprehension? So let me give you an example. So let me create a list first called oldList, which contains even numbers. And let me create a new list by using this list comprehension feature in Python. So let me just type it out for a second. All right, so what is new list gonna be? Anyone has any ideas what this would output before I walk you through like what this particular syntax would mean? Anyone want to take a wild shot? All right, if not, I'm just gonna run this. So I get 1, 3, 5, and 7. So the reason is because so the syntax here is for each element for I in old list, which is for each element in the old list, then I supply it with I minus 1 for the new list. So the first element is 2, so I minus here would correspond to 1. And then similarly for the second element, it's 4, and then I minus 1 would be 3. So hopefully that makes sense. So this comprehension syntax is basically doing the same thing as the following. So just bear with me for a second. So this is like creating a list this way. So this would output the exact same thing. So 1, 3, 5, and 7. But this is just like a shorthand in Python for doing something like this, where you like, I guess, apply a function to every element in the list, or some operation, I guess. All right. Hopefully that makes sense. I know list comprehension is one of the more mysterious syntax in Python, but hopefully that gives you a better idea of how list comprehension works. Okay, let me give you like an exercise just to test your understanding. Let me create an input array, the range range function, and then the output is going to be 2 to the I for I in input array. All right, so what is the output of this cell? Any ideas? Someone said 2, 4, 6, 8, and 16. Interesting. Any other guesses? 1, 2, 4, 8, and 16. Okay. So it turns out it is 1, 2, 4, 8, and 16 because the range operator, or the range of 5 is, oh, never mind, that's not very helpful. So this is okay. So you can think of this as like 0, 1, 2, 3, and 4. And then 2 raised to 0 is 1. 2 raised to 1 is 2, and so on and so forth. All right. Let's see, is there a question? Okay, yeah, it's totally fine. All right. So next, we're gonna be covering functions. So in Python, you would define a function using a keyword def, and then you would follow it by with the name of the function and its parameters. And so in this function, I'm just gonna triple the whatever is the input. All right, so triple of 5 is gonna be 15. So that works as expected. You can also have like default values for some of the parameters. So for example, I can do power, and then I have 2 parameters, the power and the base, but then the base has a default value of 2. So return base to the power. So if I do power of 3, then this would return 8 because this is 2 to the 3. Because the default value for the base is 2. Similarly, you can also, another way to pass in parameters into a function is by passing it by name. So I can do power equals 3. So in the first case, I'm using the ordering of the parameters to pass in the value of 3 to power. But in the second case, I could, I specified the name of the parameters, and then I set a value to it. So this is particularly useful if you have like a lot of parameters for some of the functions in some standard libraries. So you can pass in its value through its name, so it's easier that way. All right, so a pretty common question to ask at this point is what if you could have nested functions in Python? So the answer is yes. So I can define a function within a function. Let me just print something simple here. Call this. Print another line. All right, so if I call the function foo was the output of this function, any ideas? What is the output of foo? Okay, someone said bar and foo. This. So yes, that is correct. So we're calling the function foo, and then inside of foo, we define another function, and then we're calling it, and then we're printing out foo. So That's why bar comes first and then foo comes later. Okay, so what if I try to call bar directly? So what's going to happen here? Any ideas? I try to call a function as error. Yep. So I get an exception here, and it's saying the name bar is not defined. The reason is the scope of bar is not global because it's defined within another function. So you can only call bar inside of foo because of the way that it's defined. So this is useful if you want to, I guess, implement a helper function, but you don't want other people to be able to call it in the global scope. So yeah, that basically concludes everything that I want to cover in this tutorial. I'm going to stop here for some questions if there are any. Oh, someone said outside the scope. Yes, exactly. All right. Yeah, that's basically the end of the workshop. I guess let me get back to my slides.
Wait, can you go back to one of the list comprehension ones where everyone got the 1, 2, 4, 8, 16?
Yeah.
So what's that doing exactly?
Oh, okay. So, all right, let me do something similar with the I guess the for loop syntax that I was using. So the way you would read this is for every element in the range of 5, which is, let me add a cell here. So the range of 5 is 0, 1, 2, 3, and 4, because 5 is not included. And then you would raise every element in, I guess, this range object to the power of 2, or you raise 2 to the power of whatever is in this range. So I guess I can show this in the for loop.
All right.
And then I guess let me create a array as an empty list. And then I would append all the elements, or each element, I should say. So this is basically just doing something like this. So this is just a shorthand for doing what this is doing. So this is just like a feature in Python that you could use. It's completely fine if you don't have it down like the first time you learn it, because you could always write some more code and do the same thing. But this is just like, I guess, a way to write less code in Python.
Gotcha. Thank you.
All right, cool.
Yeah, it's kind of similar to like a map function in some other languages. So like it's like, at least in this case, it's like mapping a bunch of values in the first thing to a second thing, but not rewriting the initial, right? I guess.
Yeah.
You think about it.
So we did not cover the map function, but basically what the map function does is it takes in a list and a function, and it applies the function to every element in the list, and then it outputs a new list. So this is basically just doing the same thing as the map function. All right, any more questions? If not, I'm gonna start from. All right, so yeah, that's basically the end of the workshop. Thank you all for coming, and we'll see you next week. Also, please remember to fill out our feedback form. And yeah, check out our Facebook group as well as GitHub. All right, yeah, thank you guys for coming. Hopefully you guys are having a good week so far. All right, I'm gonna stop the recording.